In this video, we're going to talk about another application of the expected value process that we practiced in the last video. So in the last video, we used the expected value process to calculate the expected utility or the expected payoff of different choices that one person could make to try and identify if one choice will pay out better than another choice in the long run. Another application of that is if I know the probability for both players, then I can also find the expected payoff for both players if they played this game according to their preferences over time. Another way to say this is if these two players keep playing over time, I'm able to actually calculate in the long run who's going to be better off in this game if I know their preferences and how they're going to choose. So here's how we do this. The first part in the step is we're going to find the probability of each outcome occurring. So remember in a game, there's kind of these four different outcomes. So we're going to take the probabilities of each player and multiply them together to find the probability of each outcome. And then for each outcome, we're going to take that probability and multiply it by a particular player's payoff. And then we'll sum up all those numbers together, and that's going to give us the expected payoff for each player if they play this game. Let's go back to our Battle of the Sexes example. Let's consider in this situation that the husband definitely prefers to go to the fight. So 2/3 of the time he would pick fight. Only 1/3 of the time would he prefer to pick ballet. The wife, on the other hand, she's 50-50. She could go about one half of the time she'd go either direction. So the first step that we're going to do here is we're going to multiply each of the probabilities by each other to find the probability of this outcome. So if we wanted to find the probability that fight would occur, this one right here. Well, the probability of the husband selecting that is 2/3. The probability of the wife selecting that is 1/2. So if we wanted to find the probability of this outcome here occurring, we would multiply 2/3 times 1/2, and we would get 2/6. Okay. And we can do that for all of these combinations. So for the next one here, we would take probability 1/3 of ballet, probability 1/2 of fight to get 1/6. So we go through and we multiply each of those probabilities together. And this gives us the probabilities of each outcome occurring in the game. Now you'll notice these still all add up to 6 or add up to 1, right? 6 out of 6. So then what we do is we take the payouts for the husband, right? So the first number here are the payouts for the husband, and we multiply them by each outcome's respective probability, the probability of it occurring, and then we add all of these numbers up. So if you were doing this in Excel, this would be a sum product, right? So we want to take 2 times 2/6 plus 0 times 1/6, et cetera, through here. So if we do that here and we add all of these up, we combine like terms and everything, we end up with 5/6. So that just means that on average, he's going to walk away with 5/6 utility. Now we can also do this for the wife. So if we take the wife's payouts for each of these, and again, calculate them by each respective probability of the outcome occurring, and then we add all of those up, we find that the wife's expected payoff is 4/6. So what does this tell us? Well, it says that given their preferences, since we know that the wife is 50-50, we know that the husband is 2/3 more likely to pick fight, then in this case, if they just picked according to those probabilities, the husband is more likely to get the bigger payoff in this game. So that's telling, but however, there is also one thing we want to point out here, which is both of these are less than 1. Now, if you notice in the game, if they cooperated, if they were to come together and say, well, what do you want to do? Let's maybe coordinate and pick this together. They would both be better off picking to coordinate with each other, even if it's not their preference to do so. They would get 1. So even if they didn't want to go to the fight or the ballet, if they coordinate, they would at least get 1. If they just play their straight up preferences and their strategies here, they end up with less than 1. So this really shows an incentive to cooperate. Even if they're on the losing end of the cooperation, they still get one, which is greater than playing their strategies here. And so this has a lot of applications to what we're going to be talking about in terms of coordination in public sector games that we play. Oftentimes we do have incentives to cooperate. It just means that we need some opportunities to coordinate and communicate. So we'll talk more about the applications of this, but hopefully this video is helpful for helping you to understand how to calculate the expected payoff for each player in a game.